This is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering, in Institute of Aeronautical Engineering. So today we are going to discuss questions on various topics. Like we have already studied 5 units. Till now we have studied about photogrammetry, remote sensing, GIS, database, and water resource. So today we'll be discussing questions, long answer type questions, how the questions are applicable, which type of questions we can just go through and how to answer that type of questions that we'll be discussing today. So let us discuss on this long answer type questions, which are going how we can just solve this type of questions that we'll be discussing today. So let us start this lecture today. So the question here we can just discuss if about photogrammetry. Suppose what is the question, how the questions may occur in the examinations, and how we have to answer that questions that we'll be learning. Like suppose there is a question like outline the principles of aerial photography and discuss how they influence the acquisition and interpretation of aerial imagery. So here if we see there are different parts in the questions. Like we have principles of aerial photography. First of all, we have to understand that what are the principles of aerial photography. So in aerial photography, and how to discuss and how they influence the acquisition, and interpretation of the aerial imaging. So this is a questions like it has Bloom's taxonomy level will be understand. So first of all, what we have to how to solve this question is, first of all, we have to split this question into two parts. Like first of all, we have to learn about the principles of aerial photography. So what are the principles of aerial photography? So if you remember, when we have studied about photogrammetry, we have discussed many times. What is photogrammetry? It's art and science and technology of obtaining the information without touching the object, without touching the physical contact with the object, and finding out the information about that object. So it is very easy to get to know about the information about that object without touching it. It's like remotely we are able to use that images for the conclusion purpose. So it's like if you want to know about how to write the principles of aerial photography is the art and science and technology, first of all, of obtaining the information about physical objects and environmental by photographic and electromagnetic images. So it's the art and science of obtaining the information about the physical objects, environment by the photographic and electromagnetic images. So what are the electromagnetic images here? So the images which are obtained in the presence of sunlight, without touching the object, that all images are called as electromagnetic images. Photogrammetry is a process of measuring images on a photograph. So photogrammetry, it's a process of measuring the images of photograph by with the help of the sensors, with the help of the aerial photos. Now what is the modern photogrammetry here? So we have photogrammetry here, like in the digital photogrammetry, we just use the sensors, we collect the digital images, and we try to find out the area, and we try to find out the height of the objects in this modern photogrammetry. So it also uses the radar imaging, radiant electromagnetic energy detection, X-ray imaging, and called as remote sensing. Detection and X-ray imaging, and it is called as a remote sensing. So photogrammetry is also kind of a remote sensing, which is helpful in the process of obtaining the images without touching into the physical contact of the image. Now photogrammetry is surveying, or photogrammetry is the branch. It's a branch of surveying which maps are prepared and photographs taken from the ground or air stations. So it is a branch of surveying, we can say. Digital surveying is done with the help of this photogrammetry. We can just obtain the graphs, we can obtain the maps, we can obtain the photos to find out the more information about the images. Now, with the advancement of the photogrammetric techniques, photographs are also being used for the interpretation of geology, classification of soils and crops. So it is helpful in the techniques to find out the photogrammetric techniques, photographs, and it is also being used for the interpretation of the geology and classification of soils and the crops, etc. It is the science of making measurements from the photographs. It will help us to use this images to measure the photographs, and the photographs especially for the recovering the exact positions of the surface of the point. So whatever points exact surface should location, it can get you the information about the location of the exact surfaces. Now types of aerial photographs. So if you talk about the principles of aerial photogrammetry, we have to also discuss about the types of aerial photographs. So what are the different types of aerial photographs we use to get the information? So we use this aerial, terrestrial, close range. So we have these three types of photographs where you can see aerial, terrestrial, and close range. So aerial is series of photographs of an area of a terrain in a sequence using a precision camera. So we use a precise camera for just obtaining the information from the aerial platform. So what is the base here is in the aerial platform, you have a vehicle here is called as aeroplane or helicopters or parachutes. So we use this vehicle and we just try to capture the information about this aerial photos. Next, terrestrial type of photograph. So what is terrestrial type of photogrammetry? Here photos are taken from the fixed location. So if you remember in the photogrammetric lectures we have just discussed, we have even seen the images how that terrestrial photographs will look like, how the images are taken from the terrestrial, how the images are taken from the aerial, that all we can understand. So fixed and usually known as the position or the near ground with the camera axis as horizontal or nearly so. Now close range. What is the close range of the camera? Now camera close to the object being observed and most often used when the direct measurements is impractical. Now aerial photographs are classified into following types. So what are the classifications of the aerial photographs if you see? So photogrammetry is photographs are classified into two types. One is vertical photograph, other one is oblique photograph. So what is a vertical photograph? So while taking aerial photographs in the distinct axis are formed from the camera lens center or one towards the ground plane to tilted. So here vertical photograph is like, suppose your camera is here. So exactly this is the ground. So your exact photo of the ground will be here. So this is the vertical photograph, which is exactly 90 degrees and inclined to the ground. So vertical photograph, this will be called as vertical photograph. Okay. Now towards the ground plane and toward tilted. Oblique photograph and aerial photograph taken with an axis of the camera held with the angle between the horizontal plane and the ground and the vertical plane perpendicular to the ground. Now low oblique images shows only the surface of the earth. The high oblique images includes the horizon. Now here if you see the low oblique photograph and the high oblique photograph. Now here if you see there are two types of photos. First of all, vertical and oblique. So what is a vertical? Which is exactly vertical to the ground, it will give the photo exactly vertical to the ground. Here we can just see the top view of the building. We cannot see the side view of the building in this photo. Whereas in this oblique photo, we will see the side view as well as the top view. Side and the top both are visible. So this is the oblique photograph, and in this oblique photograph we have two types now: low oblique and high oblique. How the low oblique will be there and high oblique will be there? Low oblique photograph is the photograph which is having less inclined, like it will not show the horizon here, only less area coverage. So here it will be less area coverage, here it will be more area coverage. Okay, so less area coverage, more area coverage will be visible. So here you can just see the horizon line. So here you can just see the sky as well as the ground. So sky and ground is visible. The horizon line is visible here. Okay, horizon line is visible here. So this is how we just differentiate the photographs, low oblique, high oblique, vertical or oblique photograph, because the vertical will be like only the top view is visible, whereas the low oblique photograph, side and the top view is also visible. Whereas in the high oblique photograph, along with the side, top and horizon as well as sky is also visible in this kind of photographs. Now, how the aerial photograph influence the acquisition and interpretation of the aerial imagery. So here, if you see how they influence the acquisition in the aerial imageries, aerial photographs influence the acquisition and play an important role in assessing the risk of different natural hazards, particularly landslides. They can be used to determine whether the hill slopes are stable or not. So they can also record the history of the landslide experience in that area. For example, an area with a more than the half of the ground surface constituted in the natural terrain, which is unmodified natural environment, and there are more slopes in that. So how this aerial photograph is influencing the slope is like, they can use to determine the weather hill slopes, they can use to record the history of the landslide, it is experienced in the area, and for example in the area which is more uh, half the way to the ground surface. Now majority of the natural occurring landslides happen is in the isolated locations, like posing the threat on the ongoing development. So aerial photographs can be used to find all current and historical landslides in and around the research region to gauge the vulnerable areas to future landslides. So aerial photographs can be used to identify the different rock types. So it will help us to identify the different rock types on the rock and exposure and the arrangement of the geological structure. So it will help us to organize, it will help us to identify the different rocks which are present on the earth surface, and it will help us to tell us, it will exposure the arrangement of the geological structures in that area. So these structures are produced by the deformation process and during the tectonic movements such as faults and folds. Now geologists identify different geological features and structures based on the lineaments, and photolineaments are lines that appear on the photos and are thought of to be driven by the geological factors. Now those identified photolineaments are aligned by the linear topographical landforms, and they can be referred as the joints, faults, dikes, rocks, and contacts. So this is how we can just identify, and this is how it impacts. Now aerial photograph interpretation is also useful to assess. Aerial photograph interpretation is also useful to assess the risk of landslides, other dangers in the natural environment, in the geotechnical industry, and it will help us in interpretation of assess the risk of the landslides. Assess the risk of the landslides means wherever the landslides are going to occur, it will help us to assess the how much risk is going to this area is going to assess, and the dangers in the natural environment in the geotechnical industry. As proper interpretation of the aerial photos can reveal the historical changes to the topography and deals of the previous landslide. It will deal with the previous landslides, and it can be helping in the determining whether an area is stable or not. Now, the second question here, what we can see here is, which is very helpful to understand what type of question, how we can just determine like the different methods of scale determination on a single vertical aerial photograph, emphasizing the relationship between the ground distance and the image distance. So how we can just, what are the different methods, how we can just identify the or determine the scale of a single vertical photograph, emphasizing the relationship between the ground distance and the image distance. So here, first of all, we have to just classify these questions into two parts. So first of all, we have to find out the different methods, how we can just determine the scale of this vertical photograph and single vertical photograph. So what is a scale? If you understand what is a scale, what is a scale? So which is drawn to the scale. So it will give you the like assumed value, assumed distance on the ground. Suppose whatever distance is on the ground, it is just related to the, for example, when you are telling on the image we have 1 centimeter, same distance on the ground it may be 1 kilometer. So 1 centimeter is equal to 1 kilometer. 1 centimeter will be equal to 1 kilometer. This is how we represent the scale. So scale is like a value which we give here to just assume it on the paper. So whatever we show on the paper, that represents on the ground. If you are showing 1 centimeter on the ground on the paper, it represents 1 kilometer on the ground, or it represents 1 mile on the ground. So that is how the scale is mapped here. So we have two types of scale here, large scale and the small scale. So when you talk about the large scale, that the value will be smaller here. Suppose 1 is to 10,000. When you talk about 1 is to 10,000, or 1 is to 10,000, or 1 is to 5,000. So what is the scale larger here? So 1 is to 10,000 will be the small scale, whereas this is the large scale. Why we call it as large scale? Because it covers the less area, but it gives some more details in that. So the concept of scale of aerial photograph is same as that of map. So scale is the ratio of the distance on the aerial photograph and the distance between the same two places on the ground in the real world. So it's a ratio of distance on the aerial photograph and the distance between the same two places on the ground on the real world. It can expressed in unit equivalents, like 1 centimeter is equal to 1000 kilometers. 1 centimeter is equal to 1000 kilometers here, or 12,000 inches, or representative fraction is 1 is to 1 lakh. Now, to determine the dimension during air photo interpretation, it will be necessary to make estimates of lengths and areas which require the knowledge of the photo scale. So scale is the ratio of the distance between 2 points. It is a ratio between distance between 2 points on a image and the actual distance between the same points on the ground. So same object, like if you show, as I told you, 2 points from A or B. So these 2 points A or B, if this is the distance of 5 centimeters, so this same on the ground. So we can say same on the ground. So if this is on the paper, so same on the ground, it may be 1 kilometer. So A and B. So two points here may be 1 kilometer here. So 5 centimeter is equal to 1 kilometer on the ground. So on an image to the actual distance between the same 2 points on the ground. So scale is an important describing factor. It's a very important describing factor in the vertical aerial photography. So the scale of the photograph is determined by the focal length of the camera, flying height above the ground. So scale is the photograph which will determine the focal length of the camera, flying height of the object, and above the ground. So what is the flying height? For example, here is your aircraft. Here is your aircraft. So this will be your flying height. This will be your flying height. Okay. So this is called as H. So it is determined by the focal length of the camera and the flying height of the ground. And the focal length is distance from the middle of the camera lens and the focal plane. Now there are two methods how we can just determine the scale. So what are the method here? So method 1, if you see, scale is the ratio and distance between 2 points on a photo to the actual distance between the same 2 points on the ground. So it's a ratio between distance between 2 points on the photo and actual distance between same 2 points on the ground. So that is 1 unit on the photo is equal to X unit on the ground. So 1 unit, whatever you show on the photo, that will be equal to the X unit on the ground. So if 1 kilometer stretch of highway covers 4 centimeter on an air photo, the scale is calculated as follows. The scale of a vertical photograph is the ratio of distance of the vertical photograph is the ratio of distance on the photo and corresponding distance on the ground. So the scale of the vertical photograph is the ratio of a distance on the photo and corresponding distance on the ground. Now photo distance by ground distance. How we can just calculate the scale here is photo distance by ground distance. So or we can say distance on the photograph by actual distance between the ground. So how we can say photo distance is, suppose this is the photo. So photo here we have A, B. This is the photo here. This is photo distance. And on the actual one we have A and B. So it is like photo distance by, so photo distance, if it is 5 centimeters, so ground distance can be 1 lakh. Okay, 1 lakh centimeters, right? So 1 lakh centimeters, if we see that is the ground distance. So here if you see photo distance and ground distance, if the photo distance is 4 centimeter here, so 4 centimeter by 1 kilometer, 4 centimeter by 1 kilometer is equal to 4 centimeter by 1 lakh centimeters is equal to 1 is to or 1 by 25,000. So the scale here is 1 by 25,000. So this is how we just identify the scale. This is the one method how we can identify the scale. And what is the second method here? If you see the second method here, so scale of a photograph can also be calculated if we know focal length of the camera, height of the aircraft, and above the ground level. So scale is F by H minus H. So this is one more method we use. Scale is equal to F by H minus H. So where h is flying height of the aircraft above the sea level, and small h is height of the ground above the sea level, and f is the focal length of the camera. Now f is the focal length distance from the center of the lens from the film surface, and h is the flying height of the aircraft above the sea level, whereas small h here is the height of the ground above the sea level. Here let n is the perspective center. If the terrain is perfectly flat or plane at the mean sea level, then the h is equal to 0. So this is the actual I was talking about. So this is the ground, if you say. This is the ground. So actual distance. This is the actual distance. And here you have the photo. Okay. So this is the photo distance. Okay. So this is the actual distance and the photo distance. And this much area is going to be covered. So it will show the focal length is between, if lens is here, this is the lens, right? So this is positive, this is negative. Okay. Now distance between this positive and negative, there is a distance here. So this is called as focal length. Okay. And h is the flying height. Okay. Flying height. So this is the flying height. So this is how the scale is calculated in the second method. That is scale is equal to f by h minus h. So h minus h is f is equal to focal length of the camera, h minus h, flying height of the aircraft minus the height of the building. Now relationship between ground distance and the image distance. How it is related by the ground distance and the image distance. So in aerial photography and remote sensing, ground distance refers to the dimensions of the single pixels in an image and measured on the ground. So in aerial photograph, it refers to the dimensions of a single pixel in an image and measured on the ground. The calculation of GSD uses the focal length of the sensor array dimensions, which are properties of the sensor, and as well as the distance between and the sensor ground and the movement of the image. So to capture the D in the figure, like normally represented by the altitude of an aircraft and the orbital distance of the satellite. So this is the relationship between the ground distance and the image distance. Like remote sensing data or ground distance refers to the dimensions of single pixels in the measure on the ground, but the calculation of GSD uses the focal length and the sensor array dimensions, which are the properties of the sensor as well as the distance between the sensor and the ground on the movement of the image. So when the ground is flat, things are also as you described, and the distance is similar across the entire image, and which means that spatial resolution and the GSD are equal to the scene 1 above. So however, since spatial resolution can be used to describe the dimensions of the pixel and relate the objectives of the focus to consider the other scenarios. So the spatial resolution, so what is the spatial resolution here? So we have different types of resolution, if you remember. So spatial resolution is, what is the spatial resolution here? So the area extent, we can say, suppose this is the area. So the pixels here, it will show you about the resolution. So more number of pixels is having, more number of pixels are having high spatial resolution. Okay, high spatial resolution. Okay, so if you have the pixels like this, so this is low spatial resolution. Okay, this is how the scale is defined here. So spatial resolution of the objects across the image would deviate from the correctly calculated GSD in such a way that objects closer to the sensor and the ground are more resolute, and those who further away are less resolute. So this is about the long type answer type questions. When you come in this type of questions will come in the exam. So this is the way how you can solve the long answers questions, and you can just give the conclusion in this manner by just defining in the different categories, and just classify the questions into 2 parts and 3 parts. Based on that, you can just divide these questions. So these are the few references for this type of questions. You can just go through to find out the more content, and you can just understand about these questions and get the more information about it. So that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.